Hello architects, developers and AWS enthusiasts. In this video today, you're going to learn how you can build a serverless, reactive, container-based application for processing records from a data stream. Now, imagine, if you will, that you have a requirement to process messages from a stream, and you have to do that with a container. And right now, you've implemented that using an application that's running all of the time. Yep, that's 24 hours a day, 7 days a week, 365 days a year. The challenge you have there is the messages you are processing appear infrequently. You are paying for and operating a lot of infrastructure for an unpredictable, spiky, and sporadic workload. Of course, if you could, you'd probably use AWS Lambda, but you cannot. And in this video, you're going to learn how exactly you can do that using AWS serverless services, all in less than 10 minutes. A quick side note before we get into that, I have just launched a Getting Started with Software Architecture course on the Dome Train platform run by the brilliant Nick Chapsis. This covers the fundamentals of software architecture. Agnostic of cloud or technology stack, it provides everything you need to know to get started in the world of software architecture, from gathering business requirements right down to application-specific design patterns. Stick around to the end of this video to get a 15% discount code for this course. But for now, back to the content. Now, you might be wondering, how can I build a reactive system based on top of containers? Containers are typically long-running processes, right? Enter serverless. And you might think serverless is only for AWS Lambda, but you can actually run serverless container workloads on AWS using the Elastic Container Service and Fargate as your compute layer. This ECS and Fargate combo means you only pay for exactly what you use. Now, applications running on ECS are typically long-running services. This still doesn't feel very reactive, James. Well, with ECS, it's possible to run a one-off task. You can define a task definition and start that as a one-off run without the need for that overarching service. So all you need to run your container in a serverless way is a container that starts up, performs the work, and then shuts itself down again. Now, that all sounds fantastic, of course, but if you have a defined container and a task definition, how can you trigger that for messages coming from a stream? Let's have a look at this from an architectural perspective. Let's imagine a scenario where you have an API over here that requests are going to be received into. The API does some work and then publishes the message onto your data stream. Once the messages hit the stream, you need some consumers to pick them up. And this is where we end up with over here. Now, of course, you've defined your ECS task definition. That is ready to run. That's ready to be executed. What happens to the stuff in the middle here? Enter Amazon Event Bridge pipes and step functions. Amazon Event Bridge pipes allows you to build a point-to-point integration. So the first step of this workflow is a pipe here. That pipe will pull the messages from the stream and send them to our task. Now, you could integrate pipes directly with ECS. You could trigger your ECS task straight away, and that would work perfectly well. However, failure handling and any additional logic you might want to work around that does become a little trickier. So what you're going to do is introduce a workflow here, and this workflow will be triggered by your pipes. Pipes integrates directly with step functions. One of the steps of this workflow will then execute your ECS task. Now, there's a couple of reasons why you've got the workflow here. The first is if things fail. If this happens to fall over and break, well, at this point here, we can handle that. And you could then send your message off and store that in a queue down at the bottom here. Having that in a queue allows you to reprocess that at a later date. The second thing having a workflow is really helpful for, when you pass the message into your ECS task, you pass that in as an environment variable. Now, ECS has limits on the size of environment variables that you can pass in. So the other thing you can do with your workflow is, as a first step, store your data off into a bucket, an S3 bucket. So the first step of your workflow will store your incoming payload in S3, and it will pass that object key from S3 into your running container. From there, your container can execute, pull down the data from S3, do its work, and then refer back to the workflow and let the workflow complete successfully. Let's dive into the application code and actually have a look at this in action. Okay, so let's see this in action now. Here I am in Postman, and I'm going to send a request to my API endpoint. Excellent. Let's have a look at the AWS console now, and we'll start with the pipes themselves. You'll see there's one pipe here. The source of my pipe is a Kinesis data stream. This could equally be a Kafka data stream, whether that's Kafka hosted on AWS using managed streaming for Kafka, or Kafka that you're hosting yourself on a EC2 instance, potentially. Within the pipe, that is then sent off to the target, to the step function workflow. And as part of that start execution in step functions, we're just filtering out some of the additional data using what's called an input transformer. If you have a look at step functions now, you'll see we've got already one successful completion of our execution. That's just how fast this is. And if you have a look at this step function workflow, the first step actually generates a unique identifier, which you'll see at the bottom there. That uses the states.uuid intrinsic function. I'll pop a link in the description to how that works. The data is then stored in Amazon S3, and the ECS task is started. If you just have a look at the actual definition of this workflow and you look at this ECS run task option, when we actually run the ECS task, you need to specify the cluster to run the task on and the task definition that you're going to use. There's some networking configuration you need to provide. And then importantly, you have this container override section. And this is where you can override values for this specific execution of your task. And this is how you get this custom data into your running application. So you'll see I'm passing in the bucket key here. This is the unique identifier for the file that's stored in S3 containing the data records that have come from the stream. This ECS run task execution is also using the wait for callback pattern in step functions, which means this workflow will pause, it will wait until a point in which a request comes back into step functions to say this was a success or a failure. The task token used for that request is also passed into the running container as an environment variable. So now within your running container, you've got access to these two environment variables. You've got the key for the object in the bucket, and you've got this task token that you can use. On success, the object is deleted from the S3 bucket. Let's keep things clean and tidy. If there is a failure, if there's an error with this ECS run task, or we hit a 300-second timeout, then we will hit this catch. And the catch here will store the complete contents of this workflow execution in SQS. It will then delete the object from S3 as well, just to keep things nice and clean and tidy. If we were to run this again, we will get a new unique identifier. We've not lost any data because the data is stored in our SQS queue. If you have a look in the ECS console now, of course, this task has already completed. So if I look at all tasks and I get the last task, which is going to be that one there 3 minutes ago, you can actually see the logs that have come out of my container here. And then finally, the piece de resistance. You have a look at your DynamoDB table, and in the DynamoDB table, you have got a record stored, and you will notice that the partition key used in Dynamo matches exactly the generated customer ID by our API. This has all happened super quick. You saw just how fast that was. You might be thinking there's an awful lot of click ops there, James. You've done a lot of clicking around in the console to set this up, and you would be wrong, because this is all configured using the AWS CDK. If you come over to an IDE now, of course, this is all defined in .NET. One of the beauties of the CDK is that you can switch this to any language, and the objects and the things that you use will be broadly the same. And if you look at the processor stack, this is the important one. And if you have a look at this definition in the CDK, the first thing you do is define your task definition. Create all the roles and the permissions that the task's going to need. And then you actually specify the task definition. So we're using ARM64, we're using Fargate, importantly, to run this. We want this to be serverless, remember? And then we actually add a container to that task definition. And the CDK will actually manage bundling up your container image for you. I just specify the path here, /app/processor, and that is the path to where my Docker file lives, and I have the Docker file for actually compiling my application. This is the actual pipe. Again, with the pipe, we configure the source and target policies, we configure the permissions and the role, and then we actually define the pipe itself. And currently, pipes only has an L1 construct in the CDK, so you have to configure everything a little bit manually, but it's actually quite intuitive. You specify the role for your pipe to use, the source, in this case, our Kinesis data stream, any parameters that are specific to the source, the target, our workflow, and any parameters specific to the target. And that's it. It is as simple as that. You now have the capability to process messages from a stream using a container and doing that in a completely reactive, completely serverless way. If you've enjoyed this video, please subscribe, hit the notification bell that pops up when you subscribe. And of course, here is the 15% discount code for the Getting Started with Software Architecture course. The link for that course is in the description as well. Thank you all for watching. I will see you all next time.